All right. Physics. So the first part of the course here, we're going to be talking about mechanics. So I think I said this last week, but it's broken into 6 parts. So our first part we're looking at is mechanics, which actually is the biggest of the 6 parts.
Can I sit like?
You can move, yep.
Because it's like really hard.
Alright, so mechanics. Most of this is coming from Newton's work, F equals ma, stuff that you might have seen before already. But before we can even start talking about formulas and motion and things like that, we first have to start talking about how to measure quantities. So we'll be talking about units and dimensions first. So that's this lesson if you want to write that down. Units and dimensions. So that's what we'll start with. Okay. Got it? Yep. Okay. So these are the things we'll have a look at, but we'll start anyways by saying exactly what a unit is. So you don't have to write everything down. If you want to make some notes of things you feel is important, you can, but you should definitely always write down definitions. So if I show you a definition, you should write that down. But anyways, I think you know what the word unit means already. Yeah. So a unit is a system we use to measure quantities. So there are 3 fundamental dimensions: length, mass and time. So these are called the fundamental dimensions. So for example, the meter is what we use for measuring length. So actually, maybe before I go on, you might even want to write that down, that there's 3 fundamental dimensions, and they are length, mass, and time.
Is this lesson being recorded?
Yeah, it is.
Yeah. So I can just watch it in a motor, right?
Yes, you can. Yeah. So if you miss something, or if you don't have enough time to write it all down, you can finish it later. But we can. It's just you for the moment, so we have plenty of time. Okay, so for example, the meter is the unit and the dimension is the length. So try not to mix the 2 up, but it's not a big deal because it's not a major problem. But the unit is the meter and the dimension is the length. You can make other dimensions using these 3. So for example, the example I give is area is length squared, length multiply length. So you can build more dimensions from using these fundamental dimensions. And just a little bit more vocabulary, the size, or how much of a unit, is called the magnitude. So we use magnitude to mean size. And again, these might be, I'm sure these are words you know already. Okay. So in Ireland, UK, and most of the world except for America and what's the other country? There's 2 countries that don't use the SI system. America and It's an African country.
Metric system.
They use metric system everywhere except America, and there is an African country, I cannot remember the name of it. But anyways,
Yeah.
you've seen it before, as most people on the planet. So it's the International System of Units, is the metric system, basically used everywhere. And there are 7 base units. Would you know the 7?
Yeah. It's Newton, right? For weight is Newton.
Maybe.
Yeah.
Keep going.
No, sorry. For weight is kilogram. For temperature it's Kelvin.
Yeah.
And then for time it's second.
Yeah.
Length is meter.
Yeah.
What else is there?
What else do you know?
I mean, there's 5, right?
Yeah, no, believe it or not, Newton is not one of the basic 7. And also there's one which you would probably not have seen before, and there's one you would have seen in chemistry. What one do you think that might be in chemistry? It's used for measuring large numbers.
But the Avogadro ones.
Yeah, so what unit is that? That's moles.
Yeah.
Yeah. So anyways, the 7 base units. So the first one, of course, is the meter, which we've been talking about, which measures length. So we use M for meter, and the dimension we use capital L. Okay. So you probably want to write these 7 down. Meter, okay, kilogram, which measures the dimension of, so what does kilogram measure?
Mass.
Mass, yeah. The second, which of course measures time. Now, the ampere, yeah.
Is for current.
Very good, measures current, which we call capital I. The Kelvin
Temperature.
is temperature, very good, which we call theta, because we've already used T for time. Now the mole is a measure of amount of substance. So in other words, how much of something you have. And we use N for that. And the last one, any guesses on the last one?
No.
Now I don't know if you've ever seen it before.
No, I haven't.
Yeah, candela. And the candela, what word does that look like? If you say a word,
Candle.
yeah, so what do you think would measure then?
Heat.
Well, we kind of have something for heat already, so something else maybe. Think about a candle now. So you write heat, what else do you get from a candle?
You get different air pressure.
Keep it simple. What do people use candles for?
For light.
For light. So candela measures what's called luminosity. In other words, how bright something is. And we use a J for that. Now, this last one here is a bit weird because for high school physics anyways, we don't usually deal with problems that involve this. And it's not really a great unit because I think it's really just made for human perception. So unlike the other units here, this one depends very much on how humans perceive light. So it's not, it's just a weird one. It's just a weird one. I won't say it's unscientific. It is scientific, but it's just weird. So anyways, we won't do any problems with candela. Okay, but we will use the other 6. So you might want to write those 7 down. you doing? Which one are you on?
And
You're not writing down the full sentence, are you?
I
Okay, maybe since all the sentences have a similar structure, maybe you can just write down amp, Kelvin, mole, candela, and then the dimensions beside it. So some of these units we'll start using from the beginning, and some of them we won't see until later parts of the course. So for example, in the first semester we will see meter, kilogram, second, but that's it, and amp. We'll have to wait until the second semester before we start seeing Kelvin, mole, and candela. You got that?
Yeah.
You sure? Yeah? I can go on?
Yeah.
Okay. Okay, so they are the 7 base units of the SI system, the International System of Units. Okay, so just some dimensional analysis, some basic rules when dealing with quantities that have units. So when things have the same dimension, they can be compared or equated. So for example, it would be right for me to say 5 meters is bigger than 4 meters. I'm allowed to do this because both sides are dealing in lengths. So both sides here are length, so it's fine for me to compare. Equate means if x is in meters, if it's measuring length, then it's okay if I say x equals y, if both of these are measuring length as well. So that's the first 2 rules. If they're the same dimension, they can be compared or equated. You can also add or subtract them, multiply or divide. So basically, if they're the same dimension, you can pretty much do anything with it. Now, quantities of different dimensions may not be added or subtracted. So, of course, it's ridiculous to say something like 5 meters plus 6 kilograms. That does not make any sense. So you cannot add or subtract. That's silly. However, you can multiply or divide. So, for example, although this is wrong, you could do 5 meters divided by 2 seconds. This is actually okay. So you can multiply or divide quantities of different dimensions. This is okay to do. But you kind of know this already, because I don't think you would ever say 5 meters plus 6 kilograms. So it just kind of makes sense. Alright, so let's have a look at these as an example. So what you can do is you can write these down, and then we just have to say which is valid, which of these is valid, which of these are valid, and which of these are invalid. So first one, 5 meters plus 2 meters. 7 meters, but we just care about knowing if it's right or wrong.
Okay, yeah,
so it's right, okay. So do you want to write these down? 5 meters plus 2 meters is valid. Okay, so I'll write down here as well. So the first one was 5 meters plus 2 meters, and that is okay. Alright, the next example here, 5 meters is bigger than 2 meters. What do you think?
It's valid.
It's valid, yeah. 2 hours is bigger than 1 kilogram. equals 3 kilograms over 2 meters cubed.
Valid.
Valid or invalid?
Valid.
Valid, yep. Okay, E. 5 meters plus 2 kilograms. What do you think?
Invalid.
Yep, that's right. And lastly, F. 5 meters times 2 kilograms.
Valid.
We're saying, what did you say?
Valid.
Valid is correct. Yeah, this is valid. Okay, so that's basics. Did you write these down? I need a minute. That's okay. Yeah, that's okay.
Okay.
Yep.
Yeah.
All right. Okay, so here's another example. What are the dimensions of each of the following? X has dimension of length L, and M has dimension of mass. So I just need you to write down this information here, and then we'll do these questions one by one. So the first thing to note is that X is dimension of length, and M is dimension of mass. So note that, please. Okay. You got it? Sure.
Okay.
Yeah? Alright. So let's have a look at the first one. W equals X plus Y plus Z. So, what is the dimension of W, do you think?
Wait. X is length.
Yep.
M is mass.
Yep.
What about Z? X and Y and Z.
I didn't tell you.
Yeah.
But I don't need to tell you.
Okay. So W is what again?
Yeah, that's my question. What is W?
Oh.
What's the dimension for W? And W equals X plus Y plus Z.
Oh, okay. So X is length.
Yep.
I mean W is length. Yeah.
Y, yeah.
Yeah, it's length. Y is because you only can add it.
That's it, yeah. Y and Z must also be length,
Yeah.
because X is length and you can only add of the same dimension. So it means W's dimension is length also.
Yes.
Okay, good. Right, B. A equals XY. So what is the dimension of A? Oh, and you can use the answers from the last part as well.
Okay. So dimension of A, it could be length or it could be mass.
Well, what's
No,
X?
but it wouldn't make sense if it's mass. So X is length.
And Y?
Y could be anything.
But I'm sorry.
Okay, so it's related. Okay, I get
Yeah.
it now. Okay, so Y is also length. So A is length as well.
Length squared.
Yeah, length squared.
Length squared, yeah. Okay, C. V equals X, Y, Z. So the dimension of V, what do you think?
So it's length
Mhm.
and length,
Mm-hmm.
and the other one
Mm-hmm.
Z
Mm-hmm.
could be anything. Oh, it's that also length, so it's length cubed.
Length cubed, that's right, good. And then lastly, D, rho equals M over V. So the density of rho. Okay, so what's the not the density, dimension. So what's the dimension of M?
Mass, so density is
Yeah.
mass over volume.
Yeah, so it's mass over length cubed, which you're right, you've realized of course is volume. So that's it. So I think that's okay. So you just need to write these down. That's the second example there.
Okay.
Now, the next part of the question, question 3, maybe I can just zoom out a tad here. Question 3, we just want to write down the units for each of these. So 3a, or example 3a, okay, so what unit could you use to measure length here? In the first one, 2a,
Uh-huh.
what unit measures length?
Meter.
The meter, yeah. Okay, so the second one, what unit would that be?
It would be meter squared.
Yeah, and then C,
Meter cubed.
meter cubed, and then D,
It's mass per meter cubed.
yeah, so it'd be kilogram. Now,
Oh yeah, sorry, kilogram per meter cubed.
yeah, now we don't usually write it like this in physics, so just to note here, we usually write it like this.
Yeah.
This is the normal way nowadays to write it. It's not a big problem if you write it like this, but it's not the normal way. So we'll try to use this. So yeah, for the next question, just write the units down as well. So we have meter, meter squared, meter cubed, and then kilogram per meter cubed, just for the last one. Okay. Right, so now our first definition. So we kind of saw it in the last example, something called density, and that is a measure of mass per unit volume. So as a formula, density is mass over volume. No surprise. Yep. And of course the unit and the dimension, well, it's, as you said, it's mass per length cubed, and the unit will be kilogram per meter cubed. So the dimension is this, or with the -3 instead, which is what we really try to use, and the units is kilograms per meter cubed, but we really should use kilograms meter -3.
Okay.
It's the normal way. Okay, so that's our first definition now. So we and I shall try to avoid using the /. We don't want to use that. And we'll try our best to use the powers always.
The / is that one, right?
Yeah, this is the one we don't want to use, and this is the one we do want to use.
Okay.
And we don't want to use this, we want to use this instead. Okay, you got that? Yep, great. Okay, so here's our first example. What is the density of water if 1 litre of water has a mass of 1 kilogram? Note that 1,000 litres make up 1 metre cubed. So with this example here, I just want to show you that you can kind of deal with units as if they were constants in algebra, that all the normal algebra rules still work. So for this question here, what you know, which one is this now for? That 1 litre, no, that's not what I said, was it? I said 1,000 litres, yeah. 1,000 litres equals 1 metre cubed, yeah?
Isn't the unit for liter like that?
Well, this is, I was talking to the biology teacher about this as well. You mean big L or small L?
Yeah.
Yeah, I was talking to the biology teacher about that as well, and he's not sure either, because I think they changed it.
Oh, okay.
We got a bottle of water actually. No?
No.
Let me get one from a biology student. use small l.
Okay.
So we'll use that for the moment. Small l. Okay, what else did I tell you? I told you that 1 litre of water has a mass of 1 kilogram. Now, to be very careful here, it might be tempting to write this, but of course this is very wrong.
Yeah.
Because this is a volume, a length cubed, and this is a mass. So we won't write that. But what I could say is that the mass equals 1 kilogram. Okay? Right, so let's calculate the density. So density is mass over volume, which will be 1 kilogram. Yeah, now my volume is, I'm talking about 1 litre of water, so it'll be 1 L. Yeah, but of course L is not what we want. Now if you look at this here, you can see 1,000 L's is 1 metre cubed. So you could say, I'll put it in red here, that 1 L equals 1 over 1,000 meters cubed, or as you said, 10 to the minus 3. So a little bit of a rearrangement can make this. So this would be 1 kilogram over 1 over 1,000 meter cubed, which would be 1,000 kilograms per meter cubed, which would be, if we write it the proper way, 1,000 kilograms per meter cubed. So the point I wanted to make with this example is that you can treat you can treat units like they were, quantities that you can manipulate like this.
Okay, so always when you calculate, you have to use the SI unit, right?
Yeah. In calculation, well, certainly in answers, there are some cases where we don't have to worry about the units because the units cancel, but it's safer just to always use SI units.
Yeah, because like this, we can just change the meter to something else, right? To maybe
Could make it centimeter or something.
Yeah, so that the 1 liter equals to 1 something meter.
Oh yeah, and we could have done it as grams per centimeter cubed as well. Yeah, and we'll look at something like that in a moment. Okay, did you write this down?
No.
Yeah, write this example down. Okay, you got that?
Yeah.
Yeah. Okay. You notice I was using small v for volume, but I really probably should use big V. Okay. Right. Gram, cube. Just 1 sec. Meter squared, cube. Right, next one now. Okay, so we're talking a little bit about prefixes which we can use to make units bigger or smaller, which of course you already know because we have things like kilogram, kilometer. So some prefixes you already know. For example, 1,000 grams is 1 kilogram. 1 kilogram is 1,000 grams. 1 kilometer is 1,000 meters, and 100 centimeters is 1 meter. This is all stuff you know. So the common prefixes we use are, so the first one is, the biggest one we might use is giga, which is big G, which is 10 to the 9, which is 9 zeros. Which you would know from hard drives, gigabyte. Then the next one after that is mega, which is 1,000 times smaller, big M, that's 10 to the 6.
It's tera, giga, mega.
Yeah, that's right. I don't think we ever go as big as tera though, you're right, but there's ones bigger than tera. We only go as far as giga. Kilo, which is a K, which is 10 to the 3, which is 1,000, a very common one. Centile, which is a C, which is a 10 to the minus 2, which is 0.01. Milli is M, and that's 10 to the minus 3. And then micro is a mu, and that's 10 to the minus 6. And then nano, that is an N, and that's 10 to the minus 9, 9 zeros. So what you could do, well, you've seen this before, haven't you? Yeah. So you could at least write down the name and maybe the 10 to the power. So these are the ones which you'll need to know off by heart. Yeah, okay. So let me, again, just like with the units earlier, we can deal with prefixes as if they were quantities to be manipulated. So for example here, convert 50 kilometers per hour into meters per second. So let's have a look at this. So this is our 5th example here. Okay, so we want to convert 50 kilometers per hour into meters per second. So anyways, we know that that's 50 kilometers per hour, like that. Or you don't even have to put it over the whole thing. Now, I'll just write that again actually, but with a little bit of colour into it. So, all I'm doing here is highlighting the prefix as K. So if we go back here, we can see that the K is kilo, which is 10 to the 3, which is also 1,000. So we could write this as 1,000 meters over hour. And hour also. We know what an hour is. It's 60 minutes. So we could change that into 60 min. Of course, and we know what a minute is as well. 60 seconds. Yeah, 60 times 60. 1,000. And then we have 60. And then minute here, put in green, that's 60 seconds. And there's a little multiply here. So this would become 50 times 1,000 over 60 times 60, and the unit is meter per second. So that's what we want. We want it in meters per second. So if I just hit this in on the calculator, 50 times 1000 divided by 3600. So I would get here 13 point, and if I round it, it'd be 9 meters per second. So let's double check that. Yep, 13.9 meters per second is what it is. Okay, so there's another one for you to write down. Yeah.
How many decimal places do you
Yeah, no, we haven't talked about that just yet. That's something to worry about for the exam. But usually we like to give it to 3 significant figures, our answer. And we'll talk about this in maths class actually. So we want 1, 2, 3 significant figures for the answer. Yeah. For calculations, we should of course do more than this, but for the final answer we should stick it to 3. Okay, can you write this one down? Okay, yeah, great. Okay, one more example then. So the last one now to have a look at is 50 centimeters into meters squared. Now just before we do that actually, I'd be curious to see what you think. If I write centimeters squared, do I mean centimeter times meter squared? Or do I mean centimeter all squared, which is the same as centi squared and meter squared? So I just wonder what you think it is. If I write centimeter squared, which of the two do you think? Do you think I mean centimeter, centi dot meter squared, or do I mean centi squared meter squared? Very good, it's the second one, yeah. So we have to be very careful though, because in maths class, if I wrote xy squared, do I mean x times y squared, or do I mean xy squared?
No,
it's the first one, yeah. So we just need to be very careful about maths and physics here, that when you write in other words, if you write prefix unit squared, both get the square. The prefix gets the square and the unit gets the squared. Okay, so just be careful about that. So let's have a look at our first example of this type. 50 centimeters squared into meter squared.
Okay, so convert it.
Yeah, so let's convert that. 50 centimeters squared into meters squared. Okay, so first we shall write it like this. Centi squared, meter squared. So that's good actually, because we have the meter squared already. Centi was 0.01. So So that's 0.01 squared meters squared. So that would be 50. 0.0001 meter squared. So that would be, my goodness, 0.005 meter squared. Isn't it? I sure hope so. Yes, it is. Yeah, so that's the area as meter squared. This is important because, like you were saying earlier, well, not only that, but a lot of the formulas we might deal with might want you to use units as meter squared. So you'd have to convert this into this. But it's not too difficult. So again, we can treat the centi like it was a number. Okay, got it? Yeah, great. Okay, so what we have here is 3 questions which you can do for homework, but I mean you can start them now, and if you get them finished now, then that's great because it means you don't have any homework. So these questions, they're up on Moodle. So if you don't write them all down now, that's okay. You can go to Moodle and you can find them on Moodle, okay? But you can try these for a few minutes, or if you need to take a break for a few minutes, that's fine. But we'll start the next lesson maybe at about 12 o'clock then, okay? So if you want to try and get your homework done now, or if you need to take a break, that's fine. You were in since 9 o'clock, weren't you?
What?
You were here since 9 o'clock.
Yeah.
Yeah. What are you saying?
At Dublin 9, Pine Valley. I mean Dublin 6, sorry.
Yeah.
Yeah, and British Road.
Yeah.
Yeah, that's where I'm staying right now. And I'm host family.
That's not too far away.
Yeah, it's about an hour.
Yeah.
15 minutes actually.
Yeah, yeah. That's not too bad. That's not too bad.
If I were to read on Moodle, is it like online or do I have to write it down on paper?
There's a copy of this slide. You can
okay.
you can click that. Yeah, the video and the slide is there.
What video?
The video of this lesson will be there. Yeah. Well, I mean, there is a video there from last intake, but the video and the slide will be there.
Okay. So the slides are there, so I just have to so the exact same thing that what's here will be there.
Yeah. So don't worry about if you don't get them all done.
So how do I do the homework? Like, do I have to write it down in a piece of paper?
No. Just write it down in your notebook. You keep it. But I'll check to see if there's any problems, and we'll do the questions in the next class. So if you get the questions finished now, then I'll do all of them, and you can check if you did them right.
Okay, I'll do it now.
Yeah, but I mean, if you don't have time, then I'll do them in the next class, later in the week.